Crap again. You can use the Pythagorean theorem to find the distance between 2 points. Just like down here, there are 2 points. We're going to use the Pythagorean theorem. Sometimes points are called ordered pairs, x comma y. Step number 1, plot the points. You're going to put them on the graph. Step number 2, you're going to connect the dots. 3, you're going to draw the right triangle. You're going to stay on the streets, which means make sure they're straight.
I will try my best.
4, you're going to count the leg lengths. Remember, legs are A and B. Solve for the hypotenuse. All right, here we go. Let's do it. 3, 9. And negative 5, 4. So I'm going to put those points on my graph. 3, 9. And negative 5, 4. Step 1, plot the points. Step 2, connect the dots. Doesn't have to be perfect. Needs to be decent. Step 3, draw the right triangle. I'm going to draw my triangle like you draw slope. When you count slope, which one do you start at? The bottom dot, and count up. Turn the corner and count over. See how I stayed on the streets? I drew a vertical line going 100% straight up in the air. Then I turned the corner and I drew on the street across. Sometimes I have students that draw like this. Oops, helps if I have the lead out.
Silly rabbit.
Or like this. Or maybe it's like this. Make sure, just like slope, that you stay on the axes, right? You go straight up, you stay on that street, turn and go. Because look, here's your 90-degree angle. Now, would you get the same thing if you drew your triangle this way? Yeah. It'll be okay. It doesn't matter, but you have to stay on the street. So here we go. Let's count. 1, 2, 3, 4, 5. That's my first leg. 5 squared. Plus 1, 2, 3, 4, 5, 6, 7, 8. That's my other leg. Equals c squared. And here's why I cannot count how long that diagonal is, because it doesn't follow any grid patterns, right? It goes through parts of boxes. Some parts of it just barely touches. So you can't count how big it is because it's a decimal value. So you have to use the Pythagorean theorem to find the length of this piece. Yeah. So we're going to use our calculator. We're going to do 5 squared plus 8 squared. I'm going to do the square root of 89.
89.
What do I do now?
You have to do your conversion.
I have to convert it. What's my answer? 9.43. Approximately. I'm looking for the hypotenuse, right? The longest side, the diagonal. So since I'm looking for the hypotenuse, I'm adding the legs, squaring the legs and adding them. go. Let's try the next one. Plot your points. 4, 0. Always start at the origin. Over 4 and up 0. Go back to the middle. Origin. -7, -9. Plot the ordered pairs. Connect the dots. I cannot count that diagonal because it goes through parts of boxes, right? Doesn't go through, it doesn't stay on the grid. So since I can't count the diagonal, I have to draw the right triangle, staying on the streets. Because if I stay on my streets, I get that 90-degree right angle. And if it's a 90-degree right angle, if it's a right triangle, I can use the Pythagorean theorem. I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
Oh, yeah. Let's do 3.
Could you do 11 squared plus 9 squared?
Yes.
Both are the same. Our rules for the Pythagorean theorem are substitute, did it, simplify and solve, which is where we use our calculator. And the last step is to square root. 9 squared plus 11 squared.
202.
My answer's 202?
No, you have to do second and then x2 and then use your conversion.
Square root it.
Square root it and then use your conversion.
My answer's 202?
No, use your conversion button.
Oh.
14.21.
14.21.
I think we do.
Pythagorean theorem. Finding the distance between 2 points.